We're going to get started. We do have a keynote speaker, and then we'll get to the award ceremony. We have a few more announcements. But I do want to introduce to you at this time Garrett Hartley. Garrett is a undergraduate student here at Kent State. He is a combined computer science and physics major. He's involved with the DI Hub, and he is an aspiring entrepreneur, and we're going to listen to Garrett's journey. Thank you.
All right, hello everybody. Thanks for having me. I'm excited to get to talk to you about, well, first off myself and a little bit about what I do, and hopefully I don't put anybody to sleep in doing so. Okay. So, as what was kind of just said, I'm a senior here at Kent State University. I've got a double major in physics and computer science. I've also got minors in chemistry and robotics and embedded systems. Safe to say I'm a super nerd. That's the way I like to describe myself, at least. I've got 2 years of research experience down at the Liquid Crystal Institute here on campus. Fun fact about them, that's where the first LCD display was invented. So, all of you have phones, I'm assuming. That screen on your phone originated here at Kent State, which was pretty neat. On top of that, I've also got a year of research experience in an IoT and robotics lab here on campus where I worked as a circuit designer. I'm a big sports guy. I love sports. I grew up playing football, wrestling, and track. Something I didn't carry over into college and sometimes regret, but whatever. Hindsight's 20/20. And I launched my first company here recently called Polyvolt Technologies back in 2022. So a little bit about Polyvolt Technologies. We are a research and development-based company. And what we do is we produce and we develop highly flexible and stretchable circuits. We looked at typical circuits, things that are printed on fiberglass that are very, very rigid. And we wanted to expand electronics into new spaces that the fiberglass just couldn't take care of. You'll get to see a photo of one of our devices later on. This is just a quick overview. We've identified a number of markets that we think that this could go into, specifically sports technology, smart fabrics, and discrete medical devices. That's actually how the company got launched. We were looking at a diabetic sock, and we wanted a way to monitor the glucose levels inside of a diabetic sock without being invasive. So we needed to develop a new way of designing circuits to be able to get the sensors in there to both be comfortable for the wearer and be reasonably priced enough that somebody actually wants to buy it. And as of right now, and I'm sure that you saw it, the big football guy at the very beginning, we actually identified an initial market entry point for Polyvolt Technologies in American football, and we're really interested in trying to integrate some sensors inside of the helmets to measure for head trauma. So one big thing, especially in STEM, when we're developing new technologies, we've got to be able to identify a problem. Why is this thing important? Why is anybody ever going to care about this? Then you got to become very well versed in this problem. For us, the problem that we saw, and the one that we're tackling right now, or at least attempting to, was that every year there's nearly 70,000 reported concussions coming out of high school football players. And there's also a lot of research right now stating that up to 50% of all concussions go undiagnosed entirely, boosting that previous number. On top of this, trends over the last 10 years have shown that the number of students, number of high school players coming out for football is decreasing every single year, but the amount of concussions keep going up. And I, as a sports lover, would hate to see American football die because we didn't tackle the head injury problem. So, some current solutions that exist already. This is very important when you're starting a company, because you can have an awesome idea and you can try to launch this thing, but if there's something better already, you're gonna get nowhere with that. So to become well-versed in this market space it's a very good idea. So starting with the NCAA and the NFL, right now they're using a symptomatic and a retroactive approach. This involves what's called NFL and NCAA spotters. It's essentially independent medical staffs that set high up, here as you can see, high up in the stadium facility with a good pair of binoculars, and they are watching, waiting for somebody to get hurt, waiting to see somebody's head hit the ground real hard. They'll then contact that medical staff on the field and go, hey, I think we need to check our player out. This works. I mean, it's an attempt at least, but it doesn't give us any quantitative data. It doesn't give us any more insight on how do we take the next step in preventing concussions and keeping our players safe. The verbal exchange that then happens after these spotters identify somebody who may be hurt, it's that classic concussion test. If you'd ever gotten a concussion in a sport before, I'm sure you know it. The one where the trainer will come up to you and go, hey, Here's 3 one-syllable words. When I got hurt, my words were cat, dog, and brown. I didn't remember them, so I wasn't allowed to play after that. But they'll do a motion test afterwards to make sure that your motor functions seem good, and they might have you walk in a straight line. Now, that is a rough generalization. It is a little bit better than that now, at least I hope it is. But this introduces a huge bias coming into the players, because now it's up to the discretion of the medical staff alone, in their opinion, whether this player is fit. This is entirely based off of the conversation they're able to have with the player, as well as the way he performs on the sidelines. And this system, I mean, generally it might work, but at the highest level is still resulting in very, very scary injuries. One specifically that I talk about a lot is the injury to Miami Dolphins quarterback Tua here this last season. That was a scary event, and anybody who had ever seen it, I mean, I'm sure you'll remember it. For those of you that haven't, a quick overview, the quarterback goes in and he gets hit hard. And one of the biggest plays that ends up, especially with quarterbacks, that ends up resulting in a concussion is the quarterback's head contact with the turf. And it's something that we don't look at. It's actually called a whiplash hit. That's exactly what happened to Tua. He gets up and he tries to run back to the huddle and he falls a series of times. The spotters see this, they go, hey, we need to take him out, we need to talk to him. The medical staff declares, or at least deemed, that he did not have a concussion. He sits for the rest of the game, but then comes in the next week, and within the second quarter, gets hit in the head again and gets gurneyed out of the field and sent to a hospital. He is fine now and he's on his way back, but still, that is a scary incident to see, especially on TV, and at that high of a level, to realize that we still don't have a good system in place to make sure that our players are going to be safe. Another approach that's being used right now are these new flexible helmets, and that's the one that I'm going to get on here in a minute. What we found out is that the old 80s style helmets that were real hard, real rigid, they don't actually do much to protect the head. They seem to be more as a preventative for skull fracture. Moving forward, what researchers were able to figure out was that actually introducing some flex into these helmets really helped reduce the number of concussions. And I mean, we see this technology translate all over the place now. Even into cars, we have new flexible bumpers, we have frames now. And that's because people are realizing it's minimizing injury after crash. Here we go. So this is the difference. As you can see, this is one of the most popular football helmets right now in the industry. I mean, I don't know how many athletes are in here, but I'm sure you know names like Patrick Mahomes, Joe Burrow, all of those guys, especially quarterbacks. They end up wearing this helmet. And this is the level of which helmet deformation is capable of now. And it looks very, very, very promising. So the next step is, okay, we found a way to reduce the concussions in players, but now how about we try understanding why this happens, or let's say understand the amount of force for a specific player to get concussed. And this is the issue, because to do that, classically, we'd use electronics. And as stated before, electronics are developed and designed on fiberglass boards. Those are very rigid, very, very rigid boards. And when you try to take these boards and put them in a high-stress scenario, a volume-changing scenario like this, we get a lot of breaks. They don't do well, and they fall apart. And that's why there's been no mainstream approach here, no mainstream product that integrates these sensors into football helmets, even though it seems like the next logical step in solving this mystery. And that's where we come in, Polyvolt Technologies. So what we've done is we've used a material science approach to redesign circuits entirely. We ditched the old fiberglass and we grabbed some real stretchy elastomers, is what they're called, so fancy rubber bands essentially is what it is. We were able to come up with a method to make highly conductive elastomers, is what it's called. As you can see here, this is one of our prototypes going in, one of the prototypes we developed here recently. And this is before the finished product. After we get that top layer on, it gets a little bit hard to see the circuits. But this was our new approach to solving this problem. With this, we'd like to be able to mount these force sensing items, apparatus, onto our boards and then put them inside of the football helmets. Doing this will not only allow for data collection, but it allows for rigid circuit design. I mean, maybe not rigid is the right word, but very, very strong circuit design that will hold up with these massive hits that these big guys are delivering to the head. It'll be able to deform, and it'll be able to go back to its original shape and relay data to these medical staff on the sidelines. And with this, we do realize that every single player is a little bit unique, and their concussion threshold changes over time. That is a trend that we've been able to pick up on. I mean, that's a trend that's been known for a long time. So we'd like to implement a machine learning software addition to this that'll develop a specific player profile. That way, when we go from helmet to helmet, the player can keep all of the data, and then we can begin using machine learning to predict a range at which we need to look at this player. And this, we're hoping, will significantly reduce that 50% of undiagnosed concussions and help researchers better design helmets that'll protect the players for the long run. So a little bit about the market. I mean, whenever you've got a product, you better make sure you understand the market, because you could have an awesome idea and then it's not going to go anywhere because nobody cares about it. Our market begins with the high school level. Every year there's about 1.1 million high school football players. There's about almost $400 million a year spent on protective equipment alone. This will be pads, the refurbishing of helmets, whatever they may need. Concussion research in 2020, it's a young field and it's something that people are getting interested in, especially now, was worth about $7 billion and is estimated to be worth almost $9 billion in the next few years. Some other markets we'd like to eventually explore into are going to be hopefully the NFL, the NCAA, but starting with high school made a lot of sense to us. That's our largest volume for sure, and it requires the least amount of regulation, at least right now. Okay. And then just kind of closing, I threw a couple quotes up here that some of the mentors, some of the people that I worked for and have gotten to know as friends always used to tell me at the beginning of my journey as an entrepreneur. The first of which is, be the person who understands the most about the problem you're trying to solve, because that is the most important first step in the entrepreneurial space. If you can't identify, if you can't elaborate on the problem you're attempting to solve, then you have no defense as to why the problem you're trying to solve is crucial, why your product needs to be put through. And then another one, this one I really like, but it's a little bit of a downer. Be sure that your solution is not creating more problems. And this one's hard because we all get really, really excited when we've got something new. We go, wow, this is a great innovation. This could be the next Apple even. But we need to be careful about that, and we need to, best way to do it, at least in my opinion, is talk with people who are going to be using this product and make sure that they see more solution than they do problems with the product. And if they find more problems, well, that's good, because you figured out early what you need to change. And then the last one is continue to be curious. Innovation is what is the driving force of modern technology and thus modern entrepreneurship. And to be curious means to always be looking for ways to solve new problems and to help more people. So, if you got any questions, you can always contact me. I think this is an awesome initiative going on here, so I was really excited to be a part of it. Thank you for listening to me talk about my company and the things that I'm excited about. Yeah, thank you guys very much.
Does anyone have any questions for Garrett that you would like to ask?
Garrett, can you just talk a little bit about the number of different kind of competitions that you've been part of?
Yeah, absolutely. As it turns out, if you are a student who's interested in entrepreneurship, there are ways to get integrated into this field all over the place. You just gotta look for them. You gotta figure out who to talk to look for them. One of our starting place actually was right here at the DI Hub in this makerspace area. We've got LaunchNet right around the corner here, and they are a fantastic tool to utilize, especially as an undergraduate. They're a university-based company, probably is what they are. At least they base themselves at universities. And the entire goal of LaunchNet is to have students come in to pitch these ideas, and they'll help you do things like start companies. They'll help you do things like marketing, setting up social medias, getting grant money. That's a big one, especially in science. So they're a good first step. And then after that, actually with Polyvolt Technologies, we got involved in a number of other experiences here, all in Northeast Ohio. One's called the EEC, and if anybody's interested in that, it's the Entrepreneurship Education Consortium. Ridiculous name in my opinion, but awesome program. It is a great program, led by a guy out at Case Western. And they help you kind of with that next step. They go, okay, you've identified your product, you've identified the market. Now, how do we turn this into a tangible item? How do we turn this into something physical that we can put in front of investors? So that was our next step, as we worked with them for a little while, and they were fantastic. The information we got from them was incredible. Shortly following that, we then also got involved in the NSF I-Corps program, which for a lot of young, aspiring entrepreneurs, especially in the STEM field, this is an awesome program to get into. There's a regional level that's hosted actually right down the road at Akron, which is fantastic, and they will help you figure out, okay, here's your product. Let's boil this down to, again, the minimum viable product here. And then let's start talking to potential customers, people who are going to be using your product. Let's start refining it just a little bit. That way, we have it one step closer to a final form. And then you can go to the next step and actually get involved with distributors. You can get involved if your product is directly to a consumer. You can get involved with people who are able to do that with you. So the number of opportunities, I mean, they're endless, and sometimes it's hard to find, especially in STEM. But as long as you start looking, you're going to find them all over the place. And it's a fantastic way to get integrated into a new community, begin learning new things, and hopefully get your ideas, out there.
Any other specific questions for Garrett? Making any money yet?
Hey, it's an easy group then. What's that? Oh, making any money?
Yeah.
Research money, so grant money. Yes, we've been applying for a lot of grants. Yes, so enough. Yeah, we've been making enough. A little bit of testing. So what we're mostly focused on right now is making sure that our resistance stays low. So with developing these boards, circuitry, all of that, the biggest thing to acknowledge here is that as things move and things change, so does the resistance. And for those of you unfamiliar, essentially when you start stretching these circuits, whenever you stretch something conductive, the signal that you're putting through, the voltage drops. It's going to change a little bit. And to keep that consistent was our first challenge. And that's where we're at right now, is we're making sure that once we have our final product, that we have peer-reviewed, scientifically tested results on the biggest difference we made, and that was eliminating the static copper tracks. So that's the testing that we're involved in right now, because essentially we could bring this product to a space, but it's so different and it's so unique that they're really kind of going out on a limb trusting us that it's going to work. So to have kind of that peer-reviewed result showing that, hey, this is our new approach to conductive tracks, and have that peer-reviewed and accepted in the scientific industry already is kind of our biggest challenge right now. Not yet, but talking with the school right now. Hopefully I don't have to pay for that one. Absolutely, yeah. So the stretchable circuits, we see application all over the place. But that was the biggest issue at first. It's, all right, we have all these ideas. Where do we go with it? So, yeah, actually, initially, we looked at discrete medical technology. It was kind of our biggest thing. It was in my lab work, and we were designing a diabetic sock is what it was. So diabetics, they unfortunately develop this case called neuropathy sometimes where they lose feeling in their feet. And this is the number one causation for amputation to occur in diabetics. So we actually started with that. And that kind of twisted and turned our arm just a little bit too much because we ended up having to integrate our circuits into fabrics. But absolutely, going back to your original question, yes, we're looking at the medical space. We think simple development boards would be cool, something like an Arduino or a Raspberry Pi, so we can get these new circuits out into the hands of anybody who'd like them. Yeah. Firefighters. Oh my goodness, actually. Absolutely. No, yeah, that's a really good point. Something we'd like to do in the next couple of years is come out actually with a line of clothing that has exactly what he was just describing. Blood ox levels, heart rate, blood pressure, all of the vitals that people are interested in. And hopefully we're able to conceal that with our new stretchable and flexible technology inside of fabric that can be worn daily. That way, if let's say you are a diabetic by chance, you can now have a glucose monitor A non-invasive glucose monitored t-shirt is what it is, and you're able to go about your daily life and not have to feel like you're wearing equipment. So we see application all over the place, and that can be as good of a problem as it can be a bad one. And it took us a little while to figure out where to go initially.
Any last questions for Garrett?
We've got another
you got
one.
one over here.
So actually, the material we use right now is already totally waterproof. It's a hydrophobic material is what it is. So throw them in the washer if you want. We don't care. Yeah, exactly.
Well, Garrett, on behalf of the Ohio Academy of Science, we thank you so much for sharing your journey with us.